So how many of you are familiar with Jupyter Notebooks or Colab?
I think we all are familiar with Jupyter at least. Colab.
Yeah, so Colab is basically an online Jupyter notebook by Google, where you have like a virtual machine in your Google Drive running. It's limited to Python 3.7, I believe. So some libraries I couldn't run before on Jupyter because of that. We will be using a library called FastQuant, which is a library built on top of Backtrader. So if it makes it really easy to do backtesting. By the way, today we're not going to cover like how to do proper machine learning or any of that, but I will reach an example where we're using a classifier as part of the strategy. But the focus, because you told me you would like to learn more about how to do backtesting, so all the focus will be on that. So this is the Backtrader library. It's one of the famous like backtesting engines. The difference between this and something like Zipline would be that this is a vectorized kind of engine instead of an event-based. So with Zipline, because it's event-based, you basically have like every one buy or sell, like every one timestamp pass until you make the decision for the next. So you're going by events. In a vectorized one, you're processing the whole vector as data, and then you are passing it through the backtesting. So you basically get the same exact results. It's just a difference in how it works. The good thing about this is that it's built completely on top of pandas and pandas data frames. So you're pretty much dealing with Python only and very little of an environment that based only on the engine you're using. Now, FastQuant is built on top of Backtrader, so it uses Backtrader like at its core, but it makes it really easy to use Backtrader. And we will be jumping back and forth to the code just to show you how to understand everything in, but let's start by installing the library. So in a Jupyter notebook, if you want to run like a command line instruction or something, you can start it with a exclamation mark. So I'm going to pip install FastQuant. The first time you run this, after it installs everything, it will ask you to restart the runtime. At the end here, it will tell you to restart the runtime. So we can restart the runtime for everything to be installed. So now the runtime was restarted. I will run this again. And now everything is installed. So I'm adding another code cell here. And just to make sure everything is installed, I'm going to import from FastQuant. So there's a function called backtest, which is the main function for doing backtesting. And I'm going to import also get stock data. So we'll get the stock. This function uses Yahoo to get the stock information. So we'll go with that. And while we're at it, we'll import some stuff that we might use. So importing pandas and NumPy, and maybe for plotting, although I don't think we'll use this specifically because we'll be plotting things from pandas directly, but it's good to import it. There are other things we're going to import from FastQuant, but we'll get to that later. And now let's first just get some data. So I'll, let's say the start date is, do you have anything specific like data you'd like to do? The sample I have, I tested on the Tesla price, but we can do something else if you want.
Sorry?
Do you have any stock price specific you'd like us to play with, or?
They gave us a data set of 4 years of some stock data. Is it possible to enter that data here, like that?
Yeah, it is possible, but I don't have it on my computer right now. But I'll show you now later how it's like.
Okay.
You're basically just dealing with pandas. So as long as you can get it to a pandas data frame, the data, you can use it.
I think going with Tesla is fine.
Okay.
Unless someone have a favorite stock.
So what I have here, I specified the start date to be first day of 2017 and the first day of 2019. So we're getting the data for 2017 and 2018, basically. Maybe we'll use this data for training, and then we will test on the like 2019 and forward of the Tesla price. So let me call this DF testing, and we'll use the function get stock price, stock data. And what this takes is the symbol for the stock price, the start date and the end date, and the source by default is Yahoo. And I don't really know what this format is, but if you look at the documentation, you might find something. So we'll start with the symbol for the Tesla.
I think it is open, high, low, close, and variation. The format OHLCV.
Probably open, high, low, close, and volume. Yeah, that's true, because I have that. I saw that in the data. So the start date would be the start date that we specified here, and the end date will be the end date. Okay, and if we run this, it got the data. Let's look at it. So it downloaded the data, and we have it now in a pandas data frame. Are you guys familiar with pandas?
Yes.
Yeah. Okay, good. So this is the tail of our data, the last 5 ones. So you can see it ended in 2018, because this is the end date, so it doesn't include the last one. We do head. We're starting 2017, 3. Well, there might be also, whenever you're getting data, you might not have the full data, so it would be normal. Anyway, so this is what our data frame looks like. We have the index, which is it's a date time index. So this is not a column DT. This is the index of the data frame. We have 1, 2, 3, 4, 5 columns: open, high, low, close, and volume. We will basically only be dealing with the close. If we want to plot the data, so I can even specify just the close column. Plot. So this is how it looks like, which is very difficult to predict. Okay, if you have any questions while I'm going, just stop me at any point. So now we imported the backtest function from FastQuant, so we're going to use it. It's really very simple to use. There are a few strategies already implemented in the library. So buy and hold, for example. This is the buy and hold. MA crossover, which is moving average. So you specify a window of the like the fast upper and the slow upper. And whenever they have a crossover, you make a decision when to buy or when to sell. So we will look later on how to implement a strategy ourselves, but for now we're going to use the strategies that are already implemented. Now they have a so the first thing you pass to backtest, the function, is the strategy, And the strategy can either be an object of or a class of a strategy, like a Python class that inherits from base strategy from the library, or a string which represents one of the built-in strategies. So buy and hold, the string for it is buy and hold with an N. To find these, you can look here. These are the strategies that are already implemented. These are the aliases. So this would be buy and hold is here. We have relative strength index. I don't know most of them. I don't know what they do, but it's easy to find out because these indicators are like well documented. So anyway, we're going to just test on buy and hold. So basically, we're going to buy and never sell and find out which what the result is. We're going to pass the data, which is the pandas data frame. Like if you are loading the data from a file, you just need to get to a point where you have the data in a pandas data frame like this, and that's it. Because you're passing a pandas data frame to the backtesting engine. There are other parameters that you can pass. So I'm gonna stick with the default for everything. But like the initial cash, for example, how much you're starting with. The initial in the library is $10,000. There are other things like whether you wanted to return the history or return a plot of the result. The default is true, so by default it will plot the result. It will not return history by default. There are things like commission. So is there a commission per transaction, for example? The default is 0. So in real trading, if you want to buy or sell, you have there's a commission fee for this transaction. So in many cases, if you're having a strategy that buys and sells very frequently, in a real environment, you will probably lose a lot of money because with every transaction, you will have to pay for a fee. So we're going to deal with the commission fee of 0, just for the sake of playing around with this. But if you're more into a realistic environment, you can change this commission. And I think, yeah, and there's the short, whether to allow short selling, which I don't really know all the technicalities of it in actual trading. This is where a finance person can help you understand these, but by default, it is false. And I think that's it mostly. So we're just going to work with the default parameters for now and just do the backtest for buy and hold on this data. And that's it, really. Using this library is that simple. It just did the backtesting and it gave us all the result and a plot. So the initial cash was 10,000. This is, I think, how many times we bought and how many times we sold, because it's buy and hold. We didn't do much. Okay, so this is in the graph. You can see, how can I zoom in? Press on it. So it will give us this symbol for whenever we're buying and this whenever we're selling. So you can see we bought at the very beginning. I think there's some loss of data. That's why it bought twice. I'm not sure. But anyway, so this is the idea. And we're never selling again. So the final portfolio value is 152,000. Holy shit, if in 2 years, if you have invested in an app and in Tesla for, okay, it's 100,000 initial cash.
100,000.
That's like that's not too good to be true. So 100,000 initial cash and 152,000. That's okay. So that's your like kind of benchmark. Can you do better? Okay. Any questions so far?
I just want to ask something. We can change these parameters. For example, the starting portfolio value. We can tune it, right? Say if you want to put 1,000 and see.
Yeah. So, initial cash, let's say 10,000. So now we're starting with 10,000 and our final portfolio value is 15,206. So yeah, you can change these parameters. But I'm gonna stick with the default just to keep everything with the default to be able to compare later on. Okay, and I think this is a table summary at the end with all the values. Okay. So let's do another one just to test the other. So there's one strategy also implemented, which is the simple moving average crossover, I believe. So it basically does two moving averages, one upper and one lower, and then it whenever there's a crossover, it either sells or buys. So we'll pass the same data, and in here we need to pass the two parameters for the like moving averages, the period. So the fast period is 15, let's say, and the slow period is 40. So basically it will, what this strategy does, it calculates the moving average with a window of 15 and the window of 40. And whenever there's a crossover, it decides on selling or buying. We actually lost a lot of money. So looking at the result, it automatically plots our indicators. So the red one is the SMA of 15 and the blue one is the MSA 40. So you can see here, there was a crossover here, so it sold. Over here, there was a crossover, so it bought. And here there was a crossover, so it sold. But you can see why it doesn't work so well. Like this is a good indicator that is going down, but it's very slow to catch up on the actual indication. So it didn't catch up quickly that it's now moving up, so buy again. It actually ended up selling at the lowest peak. This is also another example where it has been moving up really quickly, but it took a while to cross over. So when it decided to buy, because of the crossover, it was already too late and it was going down, which is why such strategy never actually work well. But this is an idea of a simple strategy. Okay, any questions?
So far, so good.
Okay. Yeah.
Can you just scroll up a bit? I just wanted to see something. I'm also doing it at the same time, that's why.
Okay. I'm going to share this with you at the end, so
okay.
You don't really have to. If you want, I can share with you right now a link to be able to
No, it's all right.
view it if you want. I don't know how this works. Okay. So we're going to get to a point where we're building our own strategy, a simple one. Actually, we might not, but let me show you how this library works. So going to the code for the strategies, there is a base. Are you familiar with inheritance? Like if to inherit from a class?
Yeah.
Okay. So the base strategy, you can notice that it uses backtrader in the backend, like to do the actual trading. The only thing you need to care about is two functions, which is buy signal and sell signal. So you inherit from this base strategy, and you need to define these two functions because by default they return true. So when do you buy and when do you sell? And this is really how you would build your own strategy as custom. And if you want to add any indicator, all you have to do is to define the indicator with the name of underscore indicator. or IND. Let's do an example. So trying to find my sample code. Okay, so first I will import FastQuant. Import base strategy. So this will be the base strategy. And I will create a, let's actually do a, I don't know. The only indicator I know of is a simple moving average, but do you guys have a strategy in mind? We can implement
MACD, can we use MACD?
Can I use what?
MACD?
MACD, let's see.
It was there actually in this.
Was it one of the existing ones?
Yes, yes.
Yeah. Yes, the fourth one.
Mm-hmm.
MACD, okay. So you want us to implement it ourselves instead of using the built-in?
Actually, so
because if you want to, these are built-in strategies, right? So if you want to apply this one, all you have to do is do backtest.
Okay, yeah.
And pass the name of the strategy and the data you have. So, and here it is.
Maybe what we could do is like it probably has no value, but like try to combine two indicators together just for the sake of like implementing something ourselves.
Yeah, so let me show you just, let's do a simple example. So that's strategy. And first we're going to inherit from base strategy. So this is how you inherit in Python. And we'll define the init function. And you need to call the init function of the super, which is the base strategy initialization function. And then you define whatever you want. And what we need is to define the two functions of buy and sell. Is there an example here of the custom one? Yeah, I don't see an example here, so let's go to the code. What was it? Okay, the buy signal and the sell signal. Okay, so now in the initialization, we can actually define our indicators. So the way to define an indicator is to give it a name. So these are part of the class. So I'm using the self here. So they will be members of the class. What was the indicator you wanted to use?
MACD.
Let's look at the indicators in the library. So, and you can use any indicator from Backtrader. So basically they import a lot of indicators from the Backtrader library. So MACD, let's use that. So I'm going to import that from FastQuant. Indicators, import MACD. So let's say I call this MACD. Do you guys know what the parameters that go with MACD?
Yeah, you need a it's pretty similar to EMAC. So no
SMAC.
SMAC, yeah, thank you. So like a short term and a longer term moving average.
going to cheat a little bit and look at the source code of the implemented one just to know how to use the MACD. So strategies, MACD. Okay, so it takes the period ME1 and period ME2 and period signal. Are these things familiar with you guys?
Yes, yes.
Yes.
Okay. I'm going to copy this.
Shihab, do you remember what's the usual?
It's like 12-week average and then the 9-week average. I have written it down. Wait.
Yeah, there's like a 12. Oh, is it 12, 26, 9?
Yes.
Yes, right? Okay.
So this is 12.
Yeah, 12, 26, and 9. Those
Is
are like
the 9 is of 12, 26. The 9 is of the difference, you know.
yeah, it's the signal line, right? The
Yeah.
MACD of the MAC about the moving average of the
Yeah.
MACD.
Here they are using the crossover. Okay, so they're not doing the crossover themselves. There's a also indicator called crossover in the library where they pass like the two signals.
Mm-hmm.
But let's explore here for a bit. So we added the MAC MACD indicator with these values. And right now I'm gonna keep it just returning true, but let's see if I can print self MACD indicator at 0, see what I get. I actually don't, yeah, I think they call these functions every time. So just to do some small testing, I'm going to get data that is like a few days only. So 2017. Okay, so I already ran this, so I have now a class called test strategy. I just want to see if it will print stuff. So backtest, I passed the test strategy, and for the data, I passed this new data frame. Array assignment index out of range. Okay, I think because the MACD requires more data than what I passed like 10 days. Let's try it with the full data. Okay, so we are getting a lot of outputs, and this is the actual, I think the actual data. No, sorry, like, and here I'm printing the MACD indicator at 0. Just to show you how to use the indicator. So just by registering it, it's going to calculate automatically. So I'm really not doing any strategy here. I'm just returning true for buy. So it should buy and sell everywhere because both of them are returning true. It's actually just buying because it never maybe sold. Like it immediately sells and buys, so it's not indicating anything. But this is where you can do. I actually don't know how to use this. So do you know what this strategy is for MACD?
It's a very much, it has a lot of steps. First thing is like you have to find a 12 days exponential moving average. Then you need to find 26 days exponential moving average. And after that, the MACD line is basically the difference of the two, and then you have to find the signal. You have to find the signal line, which is the 9 days exponential moving average of the MACD, and then you have to find the histogram, which is the difference of the MACD and the signal line.
Okay.
Yeah, that's how it's done. It's too like, that's why I think they already have a predefined library for it. So because it has too many
No,
things.
we're already calculating it because of you are using the indicator from the library. Like, we're already calculating the SMAD, the MACD. I don't even know what it is, so that's why I'm asking. But like looking at their strategy, they are getting the MACD value from the indicator, and they are getting the signal value, and they are doing a crossover between the MACD and the signal value. And they are also getting the SMA, and the SMA, I think that's the difference.
Yeah, that's the histogram.
Yeah.
So
And then in the actual strategy, they're getting if the crossover is greater than 0 and this difference here is less than 0, they are buying.
Okay.
So usually, like looking at these simple, because these are all simple strategies, but like you can see, it's you can read it, like the code, you can read it, so you can learn a lot about how to implement the strategy from these examples. Maybe the MACD is like could be the more difficult one to start with. So we start with the what is it, SMA or something. I think this is a MA crossover. Yeah. So this is a simple moving average. So they define first the fast period and the slow period based on the parameters we pass to it. You can see that the class is actually just a class inheriting base strategy, similar to how we were defining the custom one. And then in the initialization, they do SMA fast and SMA slow. Yeah, so they're using the SMA indicator, and they are just passing the period. So they are doing 2 SMA indicators, one fast, one slow, and then they are using the crossover indicator, which is also, it's simply just like what this crossover does, it compares them and it returns a positive or negative value. We can even look at, if you want, at the documentation for this, but it's really just a crossover between 2 indicators. And because it's just all defined as self, like as part of the class, so all of this is getting calculated on the actual data, which means in your buy and sell signals, you can just use them. So this is returning if the self.crossover greater than 0, it means it will return true. So you're saying buy. And if it's less than 0, it means sell. So using the library, this is just how simple it is to implement kind of strategies that use these indicators, just by passing the indicators from the library as members, like this, in this case, like this self.crossover would be using these 2 indicators. And it will automatically calculate over the data, and you just use it inside the buy and sell. Now, the thing is, because this is in a vectorized engine and it's not event, this buy signal and sell signal is not being called one step at a time. It's just being applied to the whole vector. So you're calculating these indicators over the whole data and the whole vector, and you immediately know if you should buy and sell over all the points. This is why it's like these operations you're seeing here, this will not return one value. This is returning a vector basically, or an array of booleans, true or false. But you don't have to worry about all the details of how it works. Like this is how simple it is to use it. This is an Emacs strategy.
And I believe that each true or false value in that array that it might be returning is corresponding to each day.
Yeah, so it will correspond to your because all your data is indexed with your date time. Like if you remember, I told you this is the index of the data frame. It's not a column. So
Yeah.
you cannot have duplicates of this. It's like having 0, 1, 2, 3 as indexes. So all of the data is indexed by the date.
And if we were to use that, I don't know if it's possible, but like on a in real time, we would take always like the last element of the array.
Exactly, yeah. So this is different. If you want to use it in real time, in an event-driven like kind of engine, like Zipline, you will just run it one more step. But in here, you apply it on the whole vector and you take the last output.
Okay, all right.
Yeah, so this is also a very similar strategy using Emac instead of moving average or simple moving average. They're also like calculating two EMA indicators, one fast and one slow, and then doing the crossover for them. And in the buy, if the crossover is greater than 0, they buy. If the crossover is less than 0, they sell. There are multiple indicators that you can use in your in this. So here you have a list of indicators implemented from Backtrader or imported from Backtrader library, all of these. And you can easily also implement your own like indicator if you want by inheriting from this custom indicator class.
Okay, just want to ask you something. I don't know if it's a silly question. For example, there are like some machine learning strategies like naive Bayes or many other things. Are those can be implemented here? Can those be implemented here?
This is what I'm going to start doing now. So we're going to be generating a classification data out of this data we have, and then using a well, we're going to use a strategy to implement, but we're not going to implement our own strategy because there is an easy to use strategy here. Let me show you, which is called, I think it's part of custom. Yeah, the ternary strategy. So basically, you pass to this strategy in your data frame that you pass as data. You need a next column, which is a custom column, which has either 1, -1, or 0 if you want to buy, sell, or hold. So I like this because it takes you out of the of writing your own custom strategy. All you need to get at the end is a column in your data frame that indicates the class of every row, whether you want to buy, sell, or just don't do anything. And it does the job for you. And you can actually see how easy it is being implemented. So the buy signal is basically just returning if this custom indicator that you're passing, this custom column, is equal to the buy integer, which is by default 1. And to sell, is it equal to the sell integer, which is by default -1, which you can also modify these. And the custom column name is called custom, which you can also modify. But for now, we're just, when we build our data frame, we're going to create a new column in our data frame and just call it custom and put the classes of it, whether we want to buy, sell, or hold, and just use this strategy instead of like customizing a strategy ourselves.
And this added column could be generated by another algorithm, right? Not necessarily something that we implement with FastQuant.
No, we're going to use like a classifier from scikit-learn now and classify the data and get it to a point where, like, you will be doing all the processing of the data outside this library because it's like factorized and you just need a pandas data frame to do the backtesting. You just need to pass the data at the end. So it does the putting everything together and giving you the analysis.
That's the testing environment, kind of.
Yeah.
Okay. Cool.
And it has other variables like a commission and things like that that are more realistic to a real environment. Because you also can just do your own like for loop and do a simple analysis of how much your portfolio ends up with, right? At the end of the day, you're just buying and selling and adding values to it. But there are more things that you can use, like the commission fee and the short selling and all these stuff that I don't really know what they mean specifically in terms of like selling shorts and stuff like that. But that's why you would use this. And there's the indicators that you don't need to implement. If you're using indicators, you can just use them from the library already implemented. So actually, what we're going to do now, we're going to build a simple strategy that is based on a classifier, where we are classifying whether we need to sell, buy, or hold based on two simple indicators. Again, this is not going to be a good strategy. This is not going to be a good machine learning model or well-tested machine learning model. It's just a proof of concept to show you how it works. Like I don't want to, well, one, we don't have a lot of time, or like, because it can take like hours if you want to keep on going and doing it. And second, it's also part of what you want to do in your challenge to get it done. But we will get to a point where we are actually processing all the data and classifying it. And then using that classifier, actually using the data to train a classifier, and then using that classifier to predict on a new data set, which is like 2 years from the Tesla price, which we are not using for testing. And then we will evaluate how our classifier did. So the first step I will start by doing is yeah, so how are we going to decide whether we want, like if we want to generate data now to train our model on, or our classifier, how are we going to specify whether at this like date the decision that should happen is buy, sell, or hold? Do you have any ideas?
Could you repeat the question again?
Yeah, so we want to generate data now for the classifier to be able to train the classifier, which means that every date, okay, I printed so many things here. Let me clean this up a little bit. Okay, so you see these rows we have at every date, we want to be able to have another column here that says action. Like what are we going to do, buy, hold, or sell? Because we want to use this data to train a classifier. So how would you decide whether you should buy, sell, or hold?
Probably by understanding the variance between the closing dates. I don't know.
There's so many ways to make your decision. So what we're going to follow here, because I did it yesterday and I have it prepared. What I did basically was take the average of the next 5 days, like looking ahead in the future for the next 5 days, taking that average and calculating the percentage change between the closing day today and the average of the next 5 days. And based on that percentage change, if it is much bigger, it means I should buy. If it is much less, it means I should sell. And if it is within a zero range, like there isn't much change, I would just hold. It might not be a good like thing to follow, but this is part of things that you might explore and see how to decide on your actual data that you want to tell the classifier, this is the perfect scenario on which you should do. So to do that, let's just review here. We have our pandas data frame here, which has
sorry to cut you off. After you find those kind of like perfect entries or perfect actions, what will you pass in as inputs in the classifier?
Yeah, this is a good question. So what I have, which is a very simple strategy again, I'm calculating the simple moving average of window of 5 days and the simple moving average of window of 15 days, I think. And I'm using that as the input of the classifier, which is not good. It doesn't work well, but it's just an idea to show you how to do it. It's not giving you a good strategy or a solution. So what we will do now is that we will calculate the indicators on this data, these two, and get it to a point where we have a data set of all these like multiple indicators of all the data we have, and another array that has -1, 1, or 0 to be used for the classification.
All right, good.
Okay, so this is our data frame. And the first thing I'm going to do is make it a Python dictionary. So I want to take it out of I will take it I will basically take the data out of the Panda data frame. So to dictionary, and I will specify it to be lists. So what I get from this basically is a dictionary, like a Python data structure dictionary with all the data in it. So if you're familiar with dictionary, like I can specify like close, for example, I will get all the data as an array. So I just basically converted the data structure from a like a pandas data frame to a dictionary, so I can play with a little bit. And because I want to calculate the moving average of every day compared to the next 5 days. So it means I will only be caring about the close. So that's all what I'm looking at. So the close is all what I'm looking at. I think I should do this, which I'm just doing now. So I will just be using this array to calculate all the percentage change. Basically, what I want to get at the end is at this day, for example, what was the percentage change compared to the next 5 days? So I'll have an array here specifying the changes, an empty array, which I will be adding to. And I have a for loop, which goes for day in the range of from 0 to the shape of my, you know how to get the shape of a data frame? So if you want to find the size of your data, this is my data frame, and this is the shape of it. So it will give me 502 and 5. So I have 5 columns and 502 rows. So if I get 0, I will get like how many rows I have in the data. So this is a for loop for every day in the range of, so it's going from 0 till 502, which is really going to go over all the data. And this day variable here will go from 0, 1, 2, 3, 4, 5 until it reaches 502. So the reason I'm doing this, because now I can, for example, if I want to get the current close price of this day, I can do the dictionary at close and at this index. So this will give me, for this specific day, this is the current close. And now what I want is the next 5 days. So I can do from the dictionary as well at the close price. Are you familiar with doing things like this with arrays? Slicing, the term is. So using these in an array.
Yep.
Okay, so we're basically going to go from this index, whatever it is, well, going from 0 till the end. So we're getting an array of values starting at this index and until this index plus 5. So whichever day we are at, plus the next 5 days, which will be in this variable. So in here, we will have an array of the next 5 close prices based on this day. Okay. And now we can just simply get the average of these next days. We can use NumPy, get the mean of these next days. And this simply will get us the average of the next 5 days based on whatever day we are at. So we have it here. And because we have now the average of the next 5 days and we have the closing price of the current day, we can simply calculate the percentage change. So percentage change would be the next day's average minus the current close price divided by current close and multiplied by 100. This will be the percentage change compared to the average of the next 5 days.
I have a question.
Yeah.
For the next day, are you include today's closing price? If
we
like
are starting at day.
Yeah. So which means it's like 6 days.
No, because the end in a slicing will not be. Okay, let's try this. So I have here an array X. I do from 1 till 5. I will get, so 1 will be 0, this index 0. So index 1 will be at the 2. And 1, 2, 3, 4, 5. The index 5 will be the 6. But when you're doing slicing, it will get it up to here. It will not include it. The upper bound will not be included. The lower bound will be included.
Okay, wait a second. But like in the for loop, when the day is equals to 0, so the next day is include the day 0 to the day 5, right?
So it will include day 0, 1, 2, 3, 4, but the 5 will not be included.
Yeah, but day 0 is include next day, or?
The 0 is included in the next day, yeah. So we're getting the average of the 5 days, including the day we are at today. So basically, based on what I have written here, you are including the current day with the average of the calculation. So it's the current day and the 4 future days, the average of them.
Okay, I see. Thanks.
Now, if you decide to change that, you can easily like modify this and take whatever. Like if you want to just take the next 5 days and not include this current day, you would do it something like this.
Okay.
Like I told you, the things I'm doing here do not mean it is a good strategy or a good like trading thing to do. It's just like giving you a kind of framework that you can play with later on and experiment with whatever you want.
All right.
Okay, so this will be the next days for every day, and this will be the current closing price. This will be the average of the next days, and the percentage change will just be the next day's average minus the current closing price divided by the current closing price times 100. And I'm just going to, this empty array that we created here, I'm just going to append it with this price or percentage change, which means I'm just recording all of the percentage changes of the days. So now we have an array called changes that has for every day the percentage change compared to the next 5 days or the average of the next 5 days. And I can simply also add this to our data frame. So I can create a new array here, call it percentage change, and make it equal to changes, which is this array. Because we never change the order of all the data we are dealing with, so the order is still respected. So based on the index inside this array, it will match the data we have. If I look at the tail here, now we have percentage changes as a column, and it indicates the percentage change. Now we can see here, like for example, 2412, there's a like an 8% percentage change. I'm wondering how true this is. So this was 2018, 2412, 5 years, 2018. Wait, what month is it? 12, so at the end of the year, and 24. Okay, it's going to be difficult to test here, but we can also look at the actual data. Let's do. So do you guys know how to filter data from like a pandas data frame?
Yes.
Yeah, so for example, if I do so location. So when you're using this LOC, you are kind of filtering based on the index, and the index here is the timestamp. So we can do something like, let's say I want to get from 23 or 20 till 30. Okay, so this is the data. I can even plot this. I should specify like close plot because I'll get a better plot. Okay, so these are the prices. I think we have some data loss. Yeah, 24, 26. So we have the 25 missing, 29 missing, which explains these lines. Anyway, we're going to stick with the data we have. I don't really know how accurate this is, but it's coming from Yahoo, so I hope it's accurate. But this shows that actually our percentage change on the 24th is accurate. Like there is a jump here up 8%. I don't know, this was at around 59, and this was at around 65. And then it 1, 2, 3, 4, and then it also went up again. So it's the average of these 4 or 5 days compared to this price here. It might be possible to be 8%. So I think our calculations are correct. Okay. Do you have any questions before we move on?
No, it's all good for me at least.
Okay. So let's look at a simple like histogram to see the percentage change, like how much does it vary. So if I just take the, now we added a column to the data frame called percentage change. So if I just use this column and I do a plot here and the kind to be histogram. Okay, so this is our percentage change. This is the frequency, and this is the actual percentage change. So there's a lot of 0% change or almost 0. And it goes maximum like to -10 or probably maybe -15 and to 15. So this gives us an idea of how much changes there is in the actual like compared to 1 day to the next 5 days, which is why the Tesla prices would be very difficult to predict from. Okay. So now we want to move from this percentage change column to actual labels like -1, 1, or 0. How would you make the decision? Like for example, we know that there's a percentage change from today's closing price to the average of the next 5 days at 8%. Would you buy or sell or do nothing?
If the following day is negative, I will sell it.
What do you mean following day is negative?
Like if the percentage change is negative, that means I have to sell the price the day before, right? Because I'm gonna make loss in the following day.
Yeah, so here we've calculated the percentage change compared to the average of the next 5 days. So if it is going to be a negative percentage change, it means the price is going down in the next 5 days. So we're going to sell. If it's going up, which means it's positive, like here it's going 8% upper.
Which is very good.
Which means we should buy if we haven't bought.
If I didn't buy, then I'll buy. But if I have it, I will hold it.
Yeah, that's by default. So it wouldn't be your decision to hold. The decision of the classifier, you want it to be buy, right? But the strategy, if you want to buy and you've already bought, you would just hold it. So did you get what I mean?
Yeah, gist of it, yes.
Because now we're preparing data for the classifier to train from. So if your classifier at this point, what do you want your classifier to tell to command you? Like basically, you want the classifier to tell you buy. That would be a really good classifier if you have it at this date, tell you to buy, because in the next 5 days it's going to increase by 8%.
Yep.
So this is what we're going to do now. We're going to add a new basically column to the data frame. And we're going to call it label. So I'm going to start by just making a copy. So let's call this column label. And this will be equal to the percentage change. So I just have another column here, which is a copy of the percentage change. And now we will modify these values based on their value to put either -1, 1, or 0. So basically, I'm going to do a filtering of all the rows based on whether the percentage change is, let's say, less than, I mean, we need to have like 3 classes, or we can do a classifier with 2 classes only, buy or sell. But if we're going with the 3 classes, which means one of them is hold, we should have a middle point where we're not selling or buying. We're just going to hold whatever decision we've made. So let's say if the percentage change is within 0.3%, we're not going to do anything. So if the percentage change is less than -0.3, we're going to sell. So what I have here is that at this location, where this is true, the column label, I'm going to assign it to be -1. So now if I do tail again, you can notice here I had this one to be negative. Actually, it's 0.1, so it wouldn't tell us. Let me get more data before we... Okay, so this will tell us more. So this is negative 0.47, so this should turn to -1, for example. Okay, so everything stayed the same except the ones that are under -0.3. So this one, for example, on the 2112, it was -0.47, and now it's -1. So we will do the same for the other 3 classes. So if the percentage change is greater than 0.3, for example, we're going to buy. So we're going to make the label equal to 1. And if it is between -0.3 and 0.3, we're going to just hold. So the last one would be a bit more complex, but because we're going to be using 2 comparing 2 things, so we'll need the parentheses. So testing percentage change. So if the percentage change greater than -0.3 and the percentage change going to be less than 0.3, this is where we are in between. So we're not going to buy or sell, we're going to just hold, which means we're giving it a label of 0. Okay, I have something wrong here. I have a dot instead of a comma. Okay, so let's look quickly at the results. So the percentage change is -5. So -5%, we are going to sell. -5, we're going to sell. -4.5, we're going to sell. It's -0.26, we're going to hold. -0.47, we're going to sell. 8% increase, so we're going to buy. 0.34% increase, we're going to buy. 3.6, buy. -0.16, not enough for us to sell. Again, based on our decisions, so doesn't mean it's a good decision. That's where you can go and modify. This is just my way of coming up with what I would like the perfect classifier to tell me. So obviously it's not perfect and might not be good even. Just one example of what you can do. Just the point here is that you need to get to a point where you have the actual decision that you want your classifier to tell you for every day, because you're going to use this data to train your model. Any questions so far?
So good.
Yeah, so far so good.
Okay, so now we have our label of every day. Let's get now the indicators. So again, like I told you before, our data will be using like a simple SMA 5 and SMA 15 for every day. And like we're expecting to pass this to the classifier and it will tell us whether -1, 1, or 0. I do not expect it to get good results. It will be bad because this is not enough indicators to decide efficiently whether to sell, buy, or hold. But this is what we're going to do, just an example how to get to that point. So now how do we get these indicators out of this data? We're going to use actually so first I'm going to import the indicators of SMA. I don't know if I imported it before, but let's import it again. And I also don't know if I imported base strategy. I think I did. Let's import it again. So strategies. So like you saw in the when I was showing the actual strategies and how they work, whenever we pass an indicator to the inside the custom class or part of our class, it automatically calculates the indicator so we can get it. Now, I will use this without a strategy. Like, I will not even define these. I don't care about them. I will just use the actual backtesting for it to do the calculation of all the indicators for me automatically. So I'm going to define a class here. Just call it add indicator strategy. It's going to inherit from base strategy. And inside the initialization, first thing I'm going to call the super initialization function. And then I'm going to just create two indicators. So SMA5, and that's what I'm calling it, equal SMA, and the window will be, or the period will be 5, and SMA 15 indicator, and the SMA period of 15. And that's all I'm going to define in this class. So I don't care about the buy and sell at this point, because I'm not using it as an actual strategy. I'm just using it as a way to calculate these indicators easily. So now if I pass it through the backtesting function, because the backtest function takes a strategy. And this is a strategy that inherits from base strategy, so it can work. And I can pass my data. What will happen is that it will actually calculate these indicators for me. And it will go on with the strategy, but the base strategy will just return true for the buy and sell. So I don't really care about the result behind the strategy, but I care about the data itself. So there is, as part of the strategy, there is a, we can pass to return history, one of the parameters that you can do, return history, here it is. So I will return the history, make it true. And for the plotting, I will make it false, because I don't want it to plot out of this. So what this will return, it will return two things, the result and the history, like they will be in a tuple, so I can get them like this. Okay, let me also add one parameter, which is the verbose. So let's make it 0. Okay, I think we can make it false.
No, it's because you have a dot instead of a comma.
Okay. Yeah. Just to not get the like the verbal text stuff. So now we ran the actual backtesting, but we don't care about the result. We don't care about the plot. We only care about the return history. So this is what we get from the history. Okay, history is a dictionary. Good point. Let's look at history. Okay, so it's a dictionary. Yeah, okay, so we have the indicators here. History.indicators. I think we have to do this, indicators. Okay, so inside the dictionary at indicators, we have a data frame of the indicators, which have the date and our two indicators that we specify. So whatever indicators you want, you can add them here to this like not real strategy, and just pass it through backtest, get the history, and you will get the calculation of the indicators. Of course, you can do it in other ways where you're actually calling these indicators on the data frame itself and stuff, but this makes it easy just to use the actual backtest automatically and just get the indicators. So the goal now would be to take these out, these two columns, and merge them with our data frame of the data. Because the DT is going to be, it's going to match the data we have. So to do that, we'll use something from the data frame called merge, like the pandas. Let me just keep this so we can keep it as reference. So let's call this DF testing with indicators. Very long name. I don't think it's a good idea, but let's keep it. And now what we're going to do is get the actual data we have. We can even specify what things we want from it, but let's just get everything. Why not? And let's do a merge. So we're going to merge this data frame with the history, indicators, and specify from the indicators okay, I actually think we should pass. So looking at the merge function, yeah, so this is the like if we're merging two data frames, we'll need to specify which is the name of the series that is going to be matched. So so the left one, which means the our DF testing, we're going to use DT to use it as the index to be merging. And the right one, we're also going to use DT. So because this also has DT, although it is not the actual index, but it is a column moved from our data. So we're going to merge these two data frames with using the DT from the left one, which is our data, and DT from the right one, which is this history indicators. Let's see if this works. Okay, we got the data merged. So we have our data, open, high, low, close, volume. We did have a small difference where DT is not an index anymore. So let's clean it a little bit. We don't want the start ID and the start name, so let's drop these as well. So let's do a drop. And with the drop, I'm going to specify which columns I want to drop. The columns would be strat ID and strat name. Let's see if it worked. I always test every little step I'm doing because you never know when you simply have a typo or something doesn't work. Okay, so it was dropped successfully. And now let's make DT back to the index. If you're importing your own data, this is some of the cleaning that you might need to do, like to get it to the same pandas data frame that is required to be passed to the backtesting. So DT has to be the index instead of like 0, 1, 2, 3. So to do that, we're going to use a function on the data frame set index, and we're going to specify DT to be 1, and we'll do it in place. Actually, in place means that we will not, yeah, so in place. So we don't have to like say equal to a new one, it will just change it in place. If we test this or like look at the data. Okay, so now we have DT back as the index. We have our data, open, high, low, close, volume, the percentage change, the label of our classifier, and the 2 indicators. And now we're ready to build the data set for our classifier. We have our 2 indicators. We're going to use this as the input to the classifier and this as the output of, or the predicted value from the classifier. Any questions?
No.
Okay. Okay, so of course we have some not available values, because whenever we calculate the SMA, it can like be missing values from the beginning, especially. So we'll look at, for example, the head of this. I think we will get a lot of not available data. Yeah, so we will need to drop these, and because we can't use them in our training because we have, like, they don't have values. So every time I'm going to use this to extract data, I'm going to do drop not available. And then I'm going to select the SMA 5 column and the SMA 15, and I'm going to get it to a NumPy array. And this is our data that will be passed to the ScikitLearn classifier. Every one of these is the input. So I'm going to save this as X testing. And the Y testing would be also drop not available. So because we are extracting data now, so make sure every time you're dropping the not available on the whole data frame before you use it, because otherwise the order might not like get mixed up, because now you're extracting data and you're only going to be matching the input with the label based on its order inside this array. This is how the classifier will use it. So now I'm going to take the label column and also convert it to NumPy. And now I have my data ready for a classifier to be trained. Here it is. This is the input of the classifier, which is the SMA 5 and SMA 15 for every data record. And this is the label of the classifier. Okay, so now it's time to use a classifier from the ScikitLearn library. I'm going to do like a simple splitting of the data. Train and I'm going to use an SVC classifier, but it's the same input that you pass to all the classifier and the same function, so it's very easy to switch between classifiers or test multiple ones. So now I'm going to use the train test split function to split the data. So this function will return 4 things. I already called my data X testing, which wasn't a very good name, but because here we'll use X test. But anyway, so yeah. So we're going to use the function train test split. We're going to pass the X values and the Y values, and then we're going to specify the size of the splitting. So let's say 70% for testing. Actually, test size. That's too much for testing. Okay, let's make it 0.3. So the test size would be 30% of our data. And I'm just going to add a random state at the end. So random state means like this is the seed of the randomness it will use, just in case you want to get the same result every time. But so I usually use it whenever we're doing a workshop or a tutorial or something, just for everyone to get the same result when they redo it. But if you want it to be random every time, like use a random seed every time, just don't add a random state. Okay, so now we have our data split into training and testing. And now we're ready to train a classifier. So I'm going to use a support vector machine classifier from the library. Again, we're not going to discuss like classifiers and how to use them and things like that, unless you have a specific question, because that requires a completely different workshop. But this is creating, are you familiar with ScikitLearn? Have you used it or played with it?
ScikitLearn, I have basic idea about it, but I think there's other people in the team who used it much frequently than I did.
Okay, so you should be familiar with what I'm doing, right?
Yeah, well, oh, sorry, go ahead.
Please, no, I'm done.
Well, for the project, because we implemented knife base from scratch, but just for the sake of learning, but after we use knife base from ScikitLearn.
Okay, so using it will be exactly like everything else will be very similar because it uses the same input and the same output for everything. So it will just be specifying a different classifier here for CLF. So now I can like basically I can even get all the prediction directly. So CLF.fit, so I can fit the data on the train, X train and Y train, and then predict on the Y test. So I'm going to pass the, I'm going to fit on the training set, and then I'm going to predict, actually I need to pass the X test. And I will get the prediction of the classifier. And you can obviously do a lot of metrics and compare models and things like that, but I'm just going to just quickly do, just want to see how many did it get it right. So if the Y test not equal to the Y predict sum. Okay, so 74 out of how many? Let's see. What is the size of okay, so 74 out of 147 were not predicted correctly. The rest were predicted or classified correctly. This is not a only metric to look at, but this is just a quick thing to look at. But we're going to go with it. Like this is probably not a good classifier, and especially because we don't have good data that we are using as input. Like these two indicators are not enough to have a good classifier. But this is all just a basic like example. So now we have this classifier. I think yeah, we can use it. So okay, so whenever you fit, it does modify thing in place, so we don't need to save it. I was just double checking for that. So we can use CLF here to predict like new values. So now what I'm going to do is just get the Tesla price of things that our model hasn't seen already. Coming back to here. I'm going to have the end date be my start date. And then I'm going to go to 2021. So from 2019 and 22, all 2 years, I'm going to get the data. So let's call this df. And now I am ready to classify this new data to see what will my classifier do, and then run it through the backtest to see how well it's doing. So are you clear on what we have done so far, like how we got to a point where we have a classifier and now we want to use it to predict this strategy, like to use a strategy?
Yes, yeah, it's fair enough.
Okay.
For me, yeah. Let's see what others say.
Yeah, so basically now what we need to do is to we need to do the same process again to get this kind of data for the new data that we have, because this is the input of our classifier. So something like the things we did here. Yeah. So we're gonna get the results again. Instead, we're going to use df. It would be obviously good if you create functions and just make calls to functions, so you don't repeat what I'm doing now. So df merging the indicators with data with the dt, and we also dropped the other two things. And okay, here. Okay, so basically we're passing it through the backtest with the add indicator strategy that basically just adds the two indicators. We're passing df, which is this new data that we got, and we're getting it here with result and history. We are creating a df with indicators by merging the df with history indicators by using dt. And we are dropping the these two columns that comes with the history, and then we are there's still one that does the index. Okay, here it is. So we need to make the dt as the index. Okay, let's see if it works. Okay, so this is our data that we're going to be testing, or actually predicting, like for doing the actual testing of our classifier on. We have the two indicators now with the data, which means we can get these values and classify them, and then pass everything to the classifier, and then use that as a strategy. So I'm going to get the data here. Let's just call it data. And basically, from here, I'm going to take the SMA 5 and the SMA 15 and convert this to NumPy. I am not dropping the NA in this case. They're not available. I'm keeping them. Even if the value is not available, let's, like, whatever gets predicted, let it happen, and we're just going to use it, which is probably not a good idea, but let's keep it for now. Like usually you would use enough data to have the indicators, and you will just eliminate the data before. Like you would use them in the calculation, but you would not use them in the testing. But this is like just to save some time now. I'm just going to keep them. Yeah, so from here, I basically got the data from this like as NumPy integers or like NumPy inputs for my predictor, which means I can use like predict on the classifier and fastest data, and I will get. Okay, I should have removed the not available. Okay, let's drop the not available from here. So so I'm just going to ignore all the data that have not available. We look at our data now, everything is available. And we probably lost the first like few columns or a few rows in which the data had not available. But now if we do the classification, we have the results. So we have the decisions that our strategy will be doing at every timestamp. At the beginning, it's going to sell, then it's going to buy, then it's going to sell, sell, buy, which, if you remember, we were discussing this ternary strategy. All what we need to do now is to create a column in our data frame in which it has the name of custom and has 1 for buy, -1 for sell, and 0 for neutral. And we'll be able to use this strategy. And this is exactly what we will do here. So this new data frame here has the not available being dropped, and we extracted this data after we dropped the not available, which means the order should work. We just match it. So now we basically what did I call it? DF with indicators. So I'll create a column called custom, and okay, let's save the data here with our prediction. So actions. Okay, so this custom will have the values of actions. Now, if we have a peek at our data, as part of our data, we have the 2 indicators, and we have a column called custom, which has the action in which we want the strategy to follow. And now all what we need to do is call backtest as the ternary, which I think we did not import. So let's import. Okay. So backtest ternary strategy, and we can just pass the data because we use the default name for this custom column, custom. If you've used a different name, you can pass this name as a parameter to the ternary strategy, but this should be enough. Okay, and this is our classifier, basically. This is our classifier strategy. How well did it do? I don't know, we started with 100,000 and we ended up with 71,000. We lost 28,000. Let's compare to the buy and hold. Started with 100,000 and ended up with 120. Wait, what? 1 million, and holy shit, we lost a lot. Instead of making million and 100,000 on our investment of 100,000, we basically lost. So it's obviously a very bad classifier and a bad strategy. That's how we would do it.
When do you buy? If you made $1 million, is it like in 2019?
This buy and hold,
Yeah. When did it start? 2019?
2019. Yeah, this is the
Wow.
data we've collected, the new ones. Where is it? Yeah, 2019 up until 2021.
So on a $100,000 investment, someone would have made like 1 million. Wow, that's crazy.
1.2 million. I think I'm reading the numbers correct, but yeah, it's like this is our strategy. This is one.
Yeah.
Yeah, 1.2 million. I mean, like if you look at the price, it did jump.
Yeah. Wow. And even in 2019, Tesla was already like popular and people knew that. Wow.
In our strategy, we go in negative or something? I didn't see that.
Yeah,
Sorry,
we
I
lost,
didn't hear you.
Okay.
we lost $28,000 in the.
Oh.
Yeah, in
the
our
classifier.
classifier strategy, we lost $28,000.
Uh-oh.
But like I told you, the point wasn't to have a good classifier or a good strategy. It was just to show you how to do this processing.
Mm-hmm.
So I hope you benefited from this.
A lot.
Yeah,
I think
thanks
this
a
was the
lot.
most, one of the best workshop we had
Yes,
for our project.
exactly.
Yeah, it was really relevant. Well, actually, up to like testing the like actually using FastQuant, it's really similar to what we're doing. So it helps a lot to see the thought process and see you code as you go. It was really helpful. Thank you.
Yeah, it was. I'm really thankful to learn this today.
Okay, that's good to hear. So I will share this with you just to have all the everything we did. And I have been recording, so I can also upload this recording if you want it. Yeah, and you can start playing around and experimenting.
Yeah, I mean, the best thing about this is that it's very light to install and to use.
Yeah, like I'm running this on a very old computer, but because it's in Colab, so everything is in the cloud and I don't need to install anything.
But usually, oh, sorry, go ahead.
Yeah, I was just gonna say that the nice thing about this library, what I like, is that it's built on pandas, so you're still familiar, like it's still Python. You don't have to go outside your like the Python environment just to use things just specific for this library, and then like have difficulties like merging things together. So with this like ternary strategy, you don't even need to customize anything in the actual library. All you need to do is get to a point where in your data frame, you have a column that specifies whether you're buying, selling, or holding for every time, regardless of how you do it. Just get to this point and call it custom and pass it through the strategy.
And if we import our own data, the only thing we need to take care of is putting the date as the index position, right?
Yeah, exactly. So you need to get to this kind of point.
Okay.
You might need to change the column names if they are not, if you don't have column names in your data, like just to specify which one is the close, the high, things like that. And to have this as index, which is the DT, which is like easy processing to do. Like we did some stuff like that now.
Yeah. Okay.
Okay. So that will be all for today. I'm available on Discord, so also if you have questions, let me know.
Okay. Thank you so much.
And
Yeah,
I'll share a link of this now on Discord just for you to have access to it.
All right. Thank you.
Okay. Good luck.
Thank you so much.
Thank you very much.
Have a nice day.
Have a nice day.
Bye-bye.